All right. All right, and we're live. Good afternoon. We're going to wait just a few minutes to get started. We're going to wait just a bit to get started. While we're getting started, I'm going to look into the Discord. Let's see what questions we have today. What is good? Jackson, period, Liz, welcome in. First one's in. Let's see what we have today. Lots of questions I got to take a look at today. Basically, I have chemistry. And basically have these compounds here. So I have a chemistry question, have two chemistry questions, have some physics. Sarah M. Perez, Elisa, cheers. Rest, good to see you. Oh, Liz, perfect. Yeah, I think you're first. Was that you? Are you Bird? No, that's not you. But someone asked an SN2 question in the Discord. That's exactly what we're going to do today, I think. Because we're going to do some Discord questions today because there's actually a ton of questions. And we're going to start off with OChem, I think. And then someone asked a calculus question. Or this is engineering. So we're going to do some engineering today. Super excited about that. What is good, everybody? Oh, guys, the poll is not active. Hold on. Let me set up the poll. Hold on a sec. We're going to do 40 minutes on the clock for the poll. Good afternoon, everybody. Welcome into the chat. My name is Dr. Andrew, PhD in chemical engineering. Guys, we have the poll active. Give me one moment to get up the poll. Let's do a 40-minute on the clock. Let's do 45 minutes. And it's going to be basically which one is superior. Which one is superior? All right, guys, how's everyone doing? Today is Wednesday, October 22nd, 2025. We are recording, so you can rewatch this on YouTube as soon as this is over. I started posting my live streams, guys and gals. Okay. Wait, not which one. There we go. Which one is superior? All right, 45 minutes on the clock today. Poll is active starting now. Question of the day. Which one is superior? Which class is superior? Is it going to be Gen Chem, organic chemistry, physics, or calculus? Wow, y'all are cooking that up. General Chem. Got 2 votes for Gen Chem already. One for OChem, one for physics. None for calculus. What's up with that? Can I vote? I'm going to vote for poor physics and calculus. Hey, Justin. Nap time, class. Absolutely. Guys, we're going to wait just a little bit before we get started. As you already know, my name is Dr. Andrew. Question of the day is active. Let's get my website up and rolling. We're going to do some questions because we have lots of questions in the Discord today. So I think today's going to be Q&A with lots of OChem. But if we finish early, we're going to do the next topics. Guys, here's the website for Engineering Minds. Doesn't it look sick? Shouts out Jackson in the chat. Jackson, can you say, hey, that's me? And chat, can you guys do me a big favor? Say W Jackson for working on the website. It looks sick. Everyone spam W Jackson for working on this today. Okay, so Jackson said that Hugh Academy said that's me. Everyone please spam W Jackson for helping us work on the website. He basically did all the work here, okay? And he did all the coding from scratch, okay? So if you need a coder to work on your website or anything else, he can do, as far as I know, he can do any kind of code. So if you need any kind of code, hit him up, okay? And so he helped me build the website from scratch. So no templates, no Wix, no fake websites. He basically did everything from scratch. We even have this customized node system that's really sick. Super excited about that. And cool, guys. Gonna wait a few minutes to get started. And I mean a few more seconds and then we'll get started. I'm gonna get started in 5, 4, 3, 2. All right, 5 minutes on the clock. Good afternoon, everybody. Welcome into the chat. My name is Dr. Andrew Sanchez, PhD in chemical engineering. As you can see, we have the question of the day up. Which class is superior? Is it going to be A, general chemistry, B, organic chemistry, C, physics, or D, calculus? If you've been here before, make sure you comment the word new so that we know that you're new and we'll welcome you in. And if you've been here before, make sure you comment the lock emoji because you know we're about to lock in. My name is Dr. Andrew Sanchez. I go live every single week, Monday through Thursday, right around this time to answer your questions for STEM. Whether it's general chemistry, organic chemistry, math, or physics, I got you covered. Today we're going to do Q&A, but you're free to ask any questions. You can either sign up on the website for your questions here. This link is engineeringminds.co. Before we get started, I just want to let you know that I do offer private tutoring for various STEM subjects. So whether you're in high school or college, I got you covered. I offer tutoring for various math classes, including algebra, trig, pre-calculus, calculus 1, 2, and 3, physics, college physics, algebra-based physics, calculus-based physics, general chemistry, AP chemistry, organic chemistry, and engineering. You can sign up for a free consultation call by tapping this link in the bio that says book tutoring. First consultation call is totally free. And last but not least, I also have a free Discord community where you can join in, ask your questions, and drop in, meet other STEM majors and STEM members. Guys, I promise the Discord is super fun and highly supportive. So if you're looking for a community that wants to support you on your STEM journey, you need tips, you need to ask questions about STEM, physics, chemistry. You need to ask people like which engineering major should I choose? Should I do med school or grad school or industry? We are super helpful and I answer the questions in there every single day. And last but not least, if you want your question answered today live, make sure you tap this TikTok Q&A button. And last but not least, this is the third time I said that, the resource library. Let me just hide this for a bit. This is where we're going to find all the practice problems from the live streams and from my TikToks where you can sign in and see all the practice problems. This is a project that I've been working on for a long time, so super excited to be having this out here. Once again, shouts out Jackson. If you need any website work, please see Huel Academy, who commented. Huel Academy is the person who designed the entire website from scratch. All right, guys, so we are going to go ahead and get started. We're going to do some Q&A today because we got some Discord questions. We got some engineering, so I'm going to start off with engineering today, and then we're going to do organic chemistry, and whoever is the winner from the poll is active. Whoever is the winner, we're going to do that topic next. So make sure you vote up on top for whatever topic you want to see, okay? Or you can comment down your questions below or on the Discord on the website. All right, Nadia, welcome in. Justin, good to see you. And Blossom, 17, looking to pursue physics degree career-wise. Is it worth it? For career advice, guys, I'm not good at career advice. I'm more of like your academic guy because I was in academia for several years. So career-wise, I'm not your guy. But I will say, if you like physics and you want to learn and want to do a lot of math and apply your math skills, physics is for sure the way to go. Not gonna lie, guys, I kind of wish I was a physics major sometimes instead of an engineer. But it's fine because I love both anyway. Here's our first problem today. It is an engineering problem from the Discord, and it basically reads, we have to determine the velocity, potential, and stream function. Okay, yay, this is our first engineering question in a while. Determine the velocity, potential, and stream function for a uniform flow of speed u, inclined at an angle alpha to the x-axis. So I've never seen this problem before, so I'm not sure. I'm not 100% confident, guys, I'll get it right away. So I'm going to drop some equations, and then let's see how we can derive this together. Jackson says, join the Discord. Gen Chem is going to catch the dub. Okay, we got 3 votes for Gen Chem so far. And cool. So I dropped some equations that I want to kind of analyze here. We have our velocity vector here. This is u equals u times cosine alpha plus sine of alpha. Really, this means that for a velocity vector, that's going to be pretty much a circle. Is going to be a potential. It's going to be a circular potential function here. That is total German. I don't even know where to start. This is basically calculus 3, Jackson. This is basically calculus 3. So, here's where we start. Okay, we're gonna use some calculus 3 to get the velocity potential. So we're gonna read this together because I haven't done this in a cool minute. Consider a new function called the velocity potential phi, which is such that the velocity component vx and vy are obtained by differentiation of phi and x in the y directions. Okay, so I'm going to basically screenshot all these equations here. I'm pretty sure this is how we start, but like I said, it's been a while since I did this. Not 100% confident. So let's see if we can lock into this. Okay, pretty sure this is what we're going to do. So I'm going to drop in these equations. This is in the aerospace engineering chat in the Discord. All right, so the first equation says what? Guys, to this day, like TikTok updated something and like I used to never have this problem and then I've been having this problem nonstop. Okay. So guys, anyone that's just joining in, we're doing Q&A for now for the next hour, doing Q&A. And then if we finish early, we're going to move on to Gen Chem, OChem, Physics, whatever you guys want. So make sure you stick around, drop your questions, or feel free to follow along if you're taking these classes. So we have our velocity potential here. And I'm going to go ahead and derive this here. So we basically have our, let's see, that's going to be in Vx. So our Vx here equation states the partial derivative of that potential function phi, which is what we're trying to solve for. So I think we're on the right track already with respect to x, and then partial y is going to be d phi dy, partial with respect to y. So if you've never taken calculus before, I know this can look scary. And if you've taken calculus 1, well, this is calculus 3. All right, and so we have the velocity, that is the velocity, vector velocity is the gradient of the velocity potential. So right now we have the velocity here, that's going to be v equals, okay, I'm going to call that a u. Okay, that's going to be cosine of alpha in the I hat direction plus sine of alpha in the j hat direction. So that's going to be a circular path. Bro, where do you recommend to catch up with algebra topics? Me personally, I recommend Khan Academy. Guys, where do you recommend for algebra? I know some people don't like Khan Academy. I recommend Khan Academy and Organic Chem Tutor. You got me through Orgo. Thank you. I ended up passing W. Shouts out Different World. Shouts out Different World. Did you end up passing? Yay. I hope you did really well. And this is going to be equal to my gradient here. This is equal to my gradient here. So I'm thinking I can integrate this. That's how I'm going to get my solution here. If this is my gradient, I'm going to do this. I'm going to integrate this. Literally covering this in fluids. What luck. M, thank you for the little crown. Guys, the poll is up. Which one is superior? Is it going to be Gen Chem, Math, Calculus, Physics? Vote up on the top left-hand side of the screen. We're starting off with some Q&A today. Engineering. It's been a while since we did engineering, so super excited. My first thought is, guys, can I integrate this? I'm going to say my u cosine of x. Basically, my Vx is my u cosine of alpha. Okay, and I'm going to set that equal to the partial phi with respect to x. So I'm pretty sure I can just straight up integrate this, guys. I don't know if I need Laplace equations here yet. My only concern is, right, do we need gradients? Let's see. I'm going to do something that I'm not 100% sure yet. I'm going to assume that this is not a partial derivative. I'm going to assume it is a total derivative. U cosine alpha, just to make my life easier here. Okay, and then I'm going to integrate by separating the variable and call that a dx term. Now, I don't have any x's here, so that's kind of concerning here because I don't see if this is actually true. Yeah, that's what I was thinking. That's a big assumption. So maybe I gotta backtrack. Helmet said, whoa, that's a big assumption. Okay. Okay. So yeah. Yeah, because then that would just give me nothing useful here. That's just going to say u cosine alpha of x. Okay, so probably not the correct answer yet, but it's a start. Okay, so similarly here, So that's going to be my phi vector here. Similarly, I'm going to basically just call that in the I hat direction plus the j hat direction. Okay, and then just going to call that x, and my y sine alpha, okay, times y in the j hat direction. Okay, so probably not what we need to do yet here. Someone said calm down, buddy. Okay, no, it's fine, it's fine. What we can do, however, is we can say that indeed, this is gonna be equal to some function here. So let's not do it as a vector form. Let's say that this is equal to the phi equation here, and then hopefully you guys can still see that. Let's say that's gonna be my phi equation here. Phi times u in the x direction. Okay, cool. And so okay, so that's gonna be ux cosine alpha. Well, that's gonna be plus some function, and it's gonna be some function f of y. Okay, it's gonna be some function f of y. So if I can relate my velocity potential in the y direction to this function, then I should be able to solve that. So let me just highlight this real quick. And then I'm going to highlight this as my first velocity potential. Such that, now let's write my f of y in terms of that. So how would I get my f of y now? I can take my d phi dy similarly here. D phi dy is equal to my u sine of alpha. Okay. And so basically integrating that with respect to y now. Let's see if I can integrate this and solve for a function of y. That is my f prime here. Okay, that is my f prime. That's my f prime of y. Cool. So Jackson says unlocks. It's okay, buddy. It's our first time doing engineering in a while. I'm kind of lost too, I'm not gonna lie. Okay. I think I was on the right track. I think we should be good here. What if I just say that's a u cosine of alpha? Okay. Ux cosine of alpha times x. Let's try this. U times x cosine of alpha plus y sine of alpha. I think we're good here, chat. I think we are allowed to make that assumption. Okay? So namely, we have the velocity field for that potential gradient there. Okay? Cool. So that was our first problem, and then I'm gonna go into the Discord and tag that person that asked this. And I'm gonna say, yay, I got the first one. I got the first one, I think. Okay, and then next, I'm gonna go into Gen Chem here. I'm going to chemistry, and next we're gonna do a organic chemistry reaction here, question here. So again, I'm going straight from the Discord, which again is totally free, which you guys can join, and the link in the description. And if this was you by chance, if by any chance this was you that asked this question, SN1, SN2, E1, E2, please let me know by commenting down below. Cool. So it says, how are all these products formed here? How are all these products formed? So basically we have E1, E2, SN1, SN2. We're gonna have 4 different reactions. So we have 4 different reactions which are straight from the E1, E2, SN1, SN2. So basically we got to draw the mechanism, which is awesome because mechanisms are my favorite OChem topic. All right. So we got to go one at a time, which might take us a minute. So let's go one at a time. We basically have this square, okay, which is a cyclo butane, cyclobutane. This would be a, let's see, this would be a uh, one, this would be a one bromoethyl. No, I thought I tried to name it, chat, but I'm not good with nomenclature. I'm sorry. And so this is a cyclobutane group with our ethyl bromide here. Okay. And okay, so I see CH3OH. So that's methanol here. So remember, methanol is going to act as a nucleophile or a base. So that's how we're going to have our compounds through elimination and SN. Now, we also do have our bromine is primary. So that's how we're allowed to set this equal to SN1, SN2. All right. So I'm going to go ahead and start with SN2 because that's probably the easiest. And I'm going to assume SN2 first. So for SN2, we're going to go ahead and take our compound here, bromine, and we're going to do this all in one nice concerted step. So I'm going to take my methanol, which is my CH3OH, and I'm going to do a nucleophilic attack followed by a loss of leaving group. Okay. And let's see here. And okay. Now the problem is here we have CH3OH. We're going to have a methyl compound here. So that should be fine there. That should be fine. Now, if I do that, let me do that in a different step. Let me bring this down over here because we might need a couple steps here. Erase this and that. Let's do this in a couple steps. I'm going to write my MEOH here. And that's going to be my first compound here. Going in and doing our backside attack, just like that. Okay. And doing our BR left. We're now going to have OMe plus. O. It's going to be OMeH plus. And we're going to just do a quick little proton workup with our methanol. Just going to grab that proton so I can neutralize that. And that's our first one. One down, 3 to go. So our first product is going to be this one right here. It's going to be, no wait, it's going to be this one. Oh, they did a, what did they do here? Oh, they did a metal shift. Hold on. Okay, this is a little bit more complicated than I realized. They did a metal shift. My brother in Christ, how did you find your passion? Funny story, I thought my passion was music for many years. I thought my passion was music. And so I was going to lock in to be a saxophone player. And then I got brainwashed into thinking that I wanted to be an engineer. And then I started loving engineering, which is really funny. So I started gaslighting myself, guys. I kind of was like, do I want to be a musician? I'm not sure anymore. And yeah, that's kind of how it happened. So I found my passion because I basically fell in love with engineering. So it kind of happened on accident. That's my story. What about you guys? How do you guys find your passion? Guys and gals. How do you find your passion here? I'm still going to deprotonate that anyway. I'm going to still deprotonate that anyway from here. Let's see if I can do that from here in this step. The problem is I have a compound that is not in the solutions here. So I have this. Okay. I have this. What happened to that extra? Oh, I basically have this. This is a methyl, and then that's going to attack here. Is going to be an extra OMe, just like that. So this one is going to be a ring opening here. Okay, it's going to be a ring opening. How do I approach alkynes? So for alkynes, there's going to be a lot of different reactions. So question for you, did you finish reading the chapter, or did you finish going over the chapter in your class? Because once you go through all the reactions, there's a nice table at the end that I want you to memorize that table. There's a nice summary of all the reactions. There's about 10 reactions you have to memorize. So my approach for you, my suggestion for you to approach alkynes is start by memorizing that entire waterfall table. Guys, getting a little bit cooked up here. I tried to move that here. So let me start with SN1. I'm gonna start with SN1 here because I got a little bit cooked. So I'm gonna start with SN1 and do this in a couple different steps. So for SN1, I'm gonna have loss of leaving group here, and that's gonna be my carbocation intermediate. And then from here, I'm gonna do my backside attack. So I know I'm trying to make this one here. So if I'm trying to make this one, I need to basically do a hydride shift. Here we go. So this is what I was missing. Okay, let's start with SN1 first. I'm gonna do a hydride shift right over here. So the hydride shift, boom, just like that. Okay. So if I do a hydride shift, now my carbocation is gonna be over here. And I have my charge over here now. So that's called a hydride shift. And with my hydride shift, now I'm ready to go ahead and do my nucleophilic attack. Nucleophilic attack, and then I'm gonna go ahead and do my CH3OH attack over here. OH, attack that. I might need one more step to do the acid workup, which I always don't give myself enough room. I never give myself enough room for that final step. So I need to give myself a little bit more room. That nucleophile is going to go ahead and attack this carbocation. We're going to have OH2 plus and basically generate a, okay, let me write this as OH2 plus. Methanol is going to come in, H3C, and deprotonate that. Okay, so we have our first product. Now we're good. 1 down, 3 to go. Okay, so here's our first one. So that's our SN1. Do you tutor for calc? Yes, I do. Thank you, Jackson. So that's our first one. Guys, let's do a quick check-in. It's been about 28 minutes. We have a poll up on the we have a poll active here. Leslie, thank you for the heart me. Good to see you, my friend. Question of the day today is, which one is superior, chat? Which topic is superior? Is it going to be general chemistry? Vote for A. Is it B, organic chemistry? C, physics. Oh, interesting. C, physics caught up. Gen Chem, and we got just another vote for Gen Chem. So as soon as physics was catching up, Gen Chem took it over. Interesting. I thought we were going to get a lot more OChem today. None for calculus. Guys, come on. I thought this was an engineering channel, but there's no one for calculus. It started as an engineering channel, and then it turned into a chemistry channel, and now it's just there's no more math here. Okay, everybody. So here's my first problem here. And what I'm going to do is I'm going to screenshot this in the disk and drop it to the person in the Discord. And I'm going to tag them and see if they respond. And if they respond, then I'll continue on. Or if you guys want me to continue on, I'm going to say, I got the first one. Yay. Let me know if you need help on the other 3. That way I can move on to another problem, which is Gen Chem would be next with the help on the other 3. So the next problem is going to be Gen Chem. So if you're here for Gen Chem, say yay Gen Chem or W Gen Chem. On the other 3. Next problem is going to be Gen Chem. And if you want to ask your own questions, there are many ways to do so. Number 1, you can just DM me directly. Number 2, you can drop it up on the website, engineeringminds.co. Number 3, you can drop it on the Discord. Either way works. It's basically first come, first serve, my friends. First come, first serve. And the best part is I'm recording this. So if I answer your question, I'm going to post it up on my YouTube channel. Okay, and guys, we have our next problem here is a Gen Chem problem here. So we're going to lock in together. This is going to be our stoichiometry lock-in time. So if we're ready to lock in for another Gen Chem problem, comment that lock emoji. Okay, so here's a good one, guys and gals. It says when iron 3 hydroxide is mixed with phosphoric acid, iron 2 phosphate precipitate results. Okay, so I'm going to zoom in here, so I'm going to try to write as neatly as possible today. Okay, so hopefully everyone can see that. Okay, so when iron 2 hydroxide, which is FeOH2, is mixed with phosphoric acid, iron 2 phosphate precipitate results. So these are precipitate. So they wrote the reaction here. Thank God. They wrote the reaction here, and so here's our recipe. Okay, here's our recipe. And before I even look at the question, let's just double check it's balanced. Okay, let's just double check it's balanced. We have FeOH2 and H3PO4, Fe3PO4. Oh, thank you. Okay, perfect. Thank you for letting me know. So now the fact that you're here, we're going to lock in together. So pretend this is a free tutoring session. Pretend that, we're in person. Okay. So as a matter of fact, if you want, you can request to join. I'm not sure if you know how to do that, but I think somewhere on TikTok says like request to join. But again, keep in mind that you will be live. Up to you. So if 3.2 grams of FeOH2 is treated with 2.5 grams of H3PO4, how many grams of Fe3PO4 precipitate can be formed? All right. So what's the first step we got to do here? What's the first step we got to do? First thing I'm going to do is, as I always say, get out your bestie periodic table. So I'm going to go to my periodic table and I'm going to say, hey, bestie, because the periodic table is my bestie. I'm going to say, hey, bestie, I need some information. And then bestie's going to say, what do you need? And then bestie's going to say, oh. And then you're going to say, all right, I need FeOH2. So before I do anything, I'm going to call this step 1. I'm going to call this step 1. And if you've been here before, what do I always say step 1 is, guys? Guys and gals, what do I always say step 1 is? It's going to be start with what you have. Start with what you have. So before I do anything, I'm just going to write down what I have so I don't get analysis paralysis. I don't start thinking, oh, okay? I don't start thinking like, oh, I don't know what to do. My teacher didn't tell me this. I'm going to fail. I don't know how to do this. Oh, no, okay, just relax. Start with what you have. So I have 3.2 grams of FeOH2. 3.2 grams of FeOH2. Okay, good job, Leslie. Good job. Can see you're following along. Okay, and I'm gonna do what else do I have? I have 2H3. Okay, 2H3PO4. No, excuse me. I'm gonna do my mass because I have 2.5 grams of H3PO4. Okay, and then I want these molecular weights. So this is what I mean by my bestie. I'm going to go to my bestie and I'm going to get my molecular weights of each of these. I'm going to put a question mark because I don't know how many grams of Fe3PO4. So that's what I'm trying to solve for here. So I don't know how many grams of Fe3PO4 I have. Fe3PO4 I have, right? And I'm going to put my molecular weights of FeOH2. So I'm going to go to my periodic table and I'm going to say, hey, bestie, I need some information. And bestie's going to say, what do you need? So the first one is going to be FeOH2. So we're going to go ahead and carefully write each one here, Fe3PO4, 2. And then the first one is FeOH2. So if you're taking Gen Chem, you need the periodic table. Guys, 12 minutes left on the clock. Make sure you vote for the poll in the top left. Which class is superior? So we have this compound here is FeOH2 here. So the first one is Fe, that's iron. And I'm going to say I only have one of these. So I have 55.84. So I'm going to put a 55.84. Okay, plus, and then I have two of these because I have OH. So I have O plus H. I already memorized H because it's only one. So I'm going to put a 1.008. 1.008. All right, and then I'm going to put a, and then I'm going to put a, and then I'm going to put an O. Notice that I have a parentheses with a 2. Remember, the reason I put a 2 was because I put a hydroxide here, right? And so what is it for oxygen? It's 15.99, 15.99. So I'm going to go back here and put a 15.99. Let me just wait a second to see if we're all caught up here. If you understand what I'm doing so far for this problem, go ahead and drop a thumbs up to see if we're on the same page here. Basically, all I did was calculate my iron hydroxide. Let's calculate that out together. Okay, so I got 55.84 plus my 2 times my 1.008 plus a 15.99. Great. So I got 89.836. Thank you, Leslie. Thank you, Jackson. So I got my first compound here. And then whoever that person that asked this, I'm sorry, my friend, who was that? My friend, can you let me know if this is making sense so far? Okay, that's going to be 89.836 grams per mole. Okay. And guys, if anyone has any tips for me, my iPad pencil is all messed up and I'm not sure why. I think that's what I get for trying to buy a cheap pencil. 89.836 here grams per mole of my, what was that one? FeOH2. FeOH2. Okay. So that's my FeOH2 is my first one, and we got to repeat that process. Okay, that was you. Emperaz. Okay, thank you. Good. Let's keep that going. We got to do that for all of them. So the first step is a little bit tedious, but we have to keep it going. So now I have H3. So I'm going to do H3. That's a 3 times 1.008. And the best part is I'm recording this, so you're going to be able to rewatch this entire thing up on my YouTube channel later tonight. 3 times 1.008 plus my P, which is a phosphorus, which is approximately 30.973. 30.973. Okay. And I'm assuming this is a college level problem, but I'm trying my best to break it down so whether you're in high school or college, this is easy for you. And then 4 times 15.99 here. Okay, so I'm going to do that calculation here. So let me know if you get any stuck here. So someone please calculate for me. What is 1.008 times 3 plus 30.973 plus 4 times 15.99? Okay, I'm going to get a 97.957. And that's my grams per mole of, what was that again? H3PO4. That's my phosphoric acid. Okay, fun fact, not so fun fact, phosphoric acid is a really strong acid and it's highly corrosive, and if you ever work with it, be really careful. Okay. Hello, Meredy. Good evening. I'm doing fantastic. Thanks for asking. How are you doing, my friend? All right, last one, guys. Last one. I want you to lock in. So I want everyone else to calculate this one for me. Okay, I want everyone else to calculate Fe3PO42 for me so I can figure out the rest of the problem while you guys are doing that, and I can read the chat. So someone please repeat that process for Fe3PO42. I'm using my phone. Okay, I'm using my phone. Okay, so I'm using my phone, has a graphing calculator here. Okay, and hi Nana, good afternoon. 36, you got 36. Sometimes my calculator gives me different answers. Guys, maybe we should do a lesson on how to use a calculator because sometimes that is not going to work. But doctor, I'm confused. Which one of the reactants do you use to find grams of Fe3PO4? Okay, we're not quite there yet. We're about to address that. But before we do that, we got to break it down step by step. This is a little bit tedious, but we got to just break it down. So we're almost there. I just want to start by just getting all the molecular weights first, and then we'll address which one we need first. Okay, So for the last one here, I erased my periodic table. Let me get that. Let me get that here. Fe3PO4. So let's try again, guys. Let me show you how to calculate it. So I have Fe3 here, right? Fe3, and again, I'm recording this so you can watch on my YouTube channel later. Fe3, so Fe is 55.84. So I'm going to go 55.84 here, right? 3 times 55.84. 3 times 55.84. So 55.84 plus, okay, phosphorus here is going to be, so I have a 2 times a PO4. So guys, this one's a little bit tricky because we have 2 times that entire thing. So I need a little bit more space here. And do 2 times P, which is 30.973 plus another 4 times 15.99. Okay, so this is my Fe3 plus another PO4 times 2 of those here. So here's how I use my calculator here. Okay, it's important to say molecular mass, not weight. I kindly disagree because those are interchangeable. However, in physics, that is true. However, in chemistry, I kindly disagree. They are interchangeable because chemists are extra. 3 times 55.84. So I'm going to do a 3, and then let me show you my calculator here. So let me bring this down here. How do you infer what to do based on word problems? That's what we're going down. That's what we're doing. That's what we're going over right now, Merity. So I'm going to give you my thought process. I'm going to tell you what I'm thinking out loud. Okay? And I'm going to tell you what we do. Exactly like Jackson said, start with what you know. I'm sorry, how loud is this calculator? Is it really that loud? 2 times 30.973. So I'm going to do a 30.973. So notice I did a parentheses here. Notice I did a parentheses here. Loud calculator. Okay, notice I did a parentheses here. So that parentheses is super important here, right? And then that was basically, guys, I already forgot what that was. Sorry. A phosphorus, Fe3PO42. So 30.973. 30.973. I'm sorry, chat. Okay, and then a 4 times 15.99. So the person that asked about how do you do your calculations, I have one parentheses to group my phosphate group because I have 2 of those phosphate groups. Okay, so 2 of those phosphate groups require the parentheses. I really wish my teacher would have told me how to use my calculator, but that's how you do it. We have our 3 times 55. We do not need a parentheses for that part, but we do need a parentheses for this part here. Guys, if you're understanding how I did that calculation, drop a thumbs up just to make sure we're on the same page here. So I got 357.386. Okay, so I got 357.386. So if you understand how I got that 357.386, let's see some thumbs ups. Okay, thank you, Leslie. Okay, and then if you got confused, don't be shy to ask questions. I try to read every single one as they come through. Okay, so guys, I gotta do that one more time. That's 3 times 55.84 plus 2 times parentheses 30.973 plus 4 times 15.999. Okay, now we're ready to start the problem. We haven't even started the problem. It's been about like 10 minutes and we still haven't even started the problem. So my suggestion for you is don't be as slow as me. I'm trying to do it slowly so we can break it down and you can see it. But when you're doing your exam, you got to do it really quick, guys. You have to be like quick because time is limited here. So that's step 1. And then we said start with what we have. So now we have everything we need. We have the grams, we have the grams per mole. We have Fe3, we have Fe3PO42, we have FeOH2. So now we're going to actually start solving the problem. And I didn't even read the problem. So now let's go back to read the problem. It says, if 3.2 grams of FeOH2 is treated with 2.5 grams of H3PO4, how many grams of Fe3PO42 precipitate can be formed? Okay, so they're basically saying we have this and we have this, but we want this. So I'm going to do step 2. Which step 1 is start with what you have. Step 2 is convert grams into moles. Convert grams into moles. The reason that step 1 is so important that I tell every single person watching this, you need to start with what you have, is because I don't have to do any more thinking. I don't have to be worried about like, oh, which one do I need? Oh, I don't know what to do. My professor is going to fail me. No, I'm just going to go right over here because that's what I have. First things first, I have my 3.2 grams FeOH2. So Meredy, when Meredy said, how do you know what to do when you see a word problem? That's how I know what to do because I already start with what I have. So now I have these grams and I want to convert grams into moles. How do we convert grams into moles, chat? How do we convert grams into moles? Now that we already have the molecular weight, we already know how to convert that into moles. Does this have to do with limiting and excess? It does. We basically have to determine limiting versus excess. But first I want to do a molar conversion. Exactly, grams times grams per molar mass, okay? So I'm going to basically take my grams per mole, 89.836, and notice that I have it on the bottom because I want to cancel out my moles and be left on top FeOH2, okay? Notice that I have my grams here on the top here, then now I can cancel out grams here and grams here. Is everyone understanding why I divided here? Is everyone understanding this step? How I divided my 89.836? If you understand this step, go ahead and drop another thumbs up. And if you missed this, make sure you watch the latest live streams. All are up on my YouTube channel, guys, because we've done already a ton of examples going over this. Okay, if you don't understand, it's totally fine, guys. Trust me, I had no idea what was going on when I was taking chemistry. Okay, so I'm going to take my 3.2 divided by my 89.836. I got 0.035. I got 0.0356 here. Okay, so now this is my moles. So if you're understanding this, let's see some thumbs ups, just so I'll make sure everyone is still following along. Okay, and if you don't understand it, just let me know. This is my moles of FeOH2. Okay, this is my moles of FeOH2. Okay, ZMD, thumbs up. Appreciate you. Meredy, appreciate you, Meredy. Okay, and then M Perez, hopefully I'm saying that correctly. Sig figs, we don't need sig figs yet, Donovan, because we are not done with the problem yet. We do not want to do sig figs or we're going to get the wrong answer. And by the way, the poll just finished. Gen Chem won again by 1 vote. So Gen Chem's been cooking all month long, guys. So we are doing Gen Chem. We're going to continue doing Gen Chem. My goat, sorry for the off topic. Do you have knowledge in mechanical vibrations? Yes and no, twin. I know the math behind it, but I have not studied it deeply. So if you need tutoring, I can't do mechanical vibrations. But if you have like a quick question about it, I probably can do some basic mechanical vibrations because that's basically just Fourier series, and I love Fourier series. And if people are wondering what that is, that's basically an engineering class. All right, guys, so we're going to go ahead and continue this here. This is 2.5 grams H3PO4, and I'm going to repeat that process for my H3PO4. H3PO4, and again, this was a problem that was submitted to me in the Discord, and if you want to join the Discord, guys, it's totally free. So I'm basically doing live free homework help here. Okay, so now we have 2.5 grams H3PO4, and I got to repeat that process, but this time I'm going to use my molecular weight of H3PO4, which remember I said was 97.957. So I'm going to again divide here by 97.957 here. Why? Because this is my grams per mole. So if I have my grams on the bottom per mole of H3PO4, well, now I can go ahead and cancel out my grams and be left with moles. Okay? So again, if this made sense, let me know with some of those thumbs ups. And if you got a little bit lost, let me know what part I should help clarify here. So I'm going to take my 2.5 divided by my 97.957, and that way now I have my 0.02551. My pen is totally cooked now, guys. 0.00, no, 0.0252521. Remember, do not do sig figs until your very, very last calculation. Do not do any sig figs until your very, very last calculation. Okay, so let's see how we're doing here. And Perez, thumbs up, perfect. Okay, this is not algebra blocky, this is general chemistry here. Okay, and now we have our moles of phosphoric acid. Okay, so now we're ready for step 3. So guys and gals, what is going to be our step 3 here? If we have moles of each one, we have basically moles of Fe3, we have moles of FeOH2 and H3PO4. What's going to be the next step here? What's going to be the next step we got to do to get our product here? Remember, this is the recipe. So if you were here in the previous live streams, we talked about that reactions are recipes. So I want you to think about this recipe here. Let's zoom in on this recipe. This basically calls for 3 bananas plus 2 cupcakes equals 1 banana cake, okay, and 6, cups of pudding. You know what I mean? It's basically literally the recipe. So if you get confused about 3OH2 plus 2H3PO4, just convert it in your mind to bananas or whatever is your favorite recipe. Okay? Everyone, do me a big, big favor. Everyone comment your favorite food down below. Everyone comment your favorite food or favorite dish down below. Okay? Everyone let me know what's your favorite dish so that we can get in the mindset of that it's literally no different than just making a food here. So I'm seeing my recipe here and I'll go first. Okay, my favorite dish is probably my mom's good old basically like chicken and rice. Okay, it's just like really, really just bomb chicken and rice is my favorite dish. Okay, Jackson said banana cake, pie, cup noodles, real, brownies, pozole. Okay, absolutely. Okay, now I'm starving here. Maybe I'm just hungry. And now I'm thinking about food here. But that's what I want you to realize when we're doing general chemistry, it's literally nothing other than doing a recipe. So for step 3, we got to do a mole to mole conversion here. Okay, so everyone said their favorite food, so thank you for that. Now for step 3, we got to do a mole to mole conversion. Okay, convert moles to moles. So, and convert moles to moles. So I'm going to do basically my molar ratio, okay, based on what I have. So when someone asked me, how do you know what to do, how to do word problems? You might feel overwhelmed, you might feel confused. Well, this is how the logic flows. I start with what I have. Remember, what do I have? Oh, I have my 0.035621 moles of FeOH2. So I'm going to just copy and paste that. I'm just going to take whatever I have here, and then I'm going to do my 0.03561 moles of FeOH2. Okay, we're going to do another quick poll here. And then I'm going to ask you, what's our conversion factor based on the problem statement? So let's do a quick poll here. Okay, so let's do this poll here. Now I'm getting really hungry, guys. You guys are still talking about food. Oh my gosh, now I'm really hungry. Huh? Okay, so which one's going to be our conversion factor? Is it going to be 1 Fe3PO4 2, or is it going to be 6 H2O? And try to read the problem carefully, okay? So which one is our conversion factor? Is it going to be 1 Fe3PO4 2 or 6 H2O? So you have about 3 more seconds to think about it. If you think it's going to be 1 Fe3PO4 2, you're going to vote for a happy face emoji. And if you think it's going to be a 6H2O, you're going to vote for a crying emoji. All right, 60 seconds on the clock. Vote down below. All right, very good, very good. So we basically got 2 votes coming in. And Perez says happy face. We got 3 happy face coming in. Good job, good job. Donovan, happy face. Nadia, M. Perez, very good, everyone. So we got 38 seconds on the clock. If you don't know, that's totally fine. Just guess. Okay. If you don't know, just guess. There's no wrong answers here. All you have to do is just pick which one is the correct answer here. Okay. Okay. Guys, thank you for the love. We're about to hit 4.7K likes. Got 8 new followers today, and we're about 55 minutes into the live stream. If anyone's new here, my name is Dr. Andrew, and I'm going live every single week to answer your questions here. And we're basically doing this Gen Chem here. So let's go ahead and see what is the results. Okay, a few more seconds left. 3, 2, 1, and very good. So everyone cooked that up. So if you said happy face, you are correct. Okay, so if you said happy face, you are correct. Okay, if you said crying emoji, good job anyway. Thank you for voting. And let's go ahead and read this problem one more time. Remember, we want to convert that into our limiting reagent here. We want to determine the limiting reagent. So it basically said we want, okay, it says how many grams of Fe3PO4. So I'm going to look at my Fe3PO4. That's why the answer was happy face. Okay, so the answer here was happy face. So that's why I said Fe3PO4. So now I have my molar ratio. So what am I trying to get? I'm trying to convert my 3 moles of FeOH2 to my 1 moles of FePO42. Okay, this part's really important. So everyone try to follow along. Notice I have a 3 over here, 3 to 1 ratio. So 3 to 1 ratio is going to be my molar ratio here. I'm going to bring this down here, and I'm going to divide by my 3 moles of FeOH2, okay, times my 1 mole of my phosphor. That was my, let's see, that was OH2 on the bottom, yep, times my Fe3PO42. Fe3, okay, PO42. Fe3PO42. And we're basically gonna cancel out moles and moles, so that's why we have our moles of Fe3PO42. So I'm gonna take my 0.035621 divided by 3. So someone please calculate 0.035621 divided by 3. Let me know what you get down below. I'm gonna get 0.011873, and this is basically my moles of product formed from FeOH2. Okay, this is my moles of product formed from FeOH2. So I'm going to write this down, and you already know what I'm going to ask you next, chat, because we are going to calculate the limiting reagent. Okay, this is moles of Fe3PO42, okay, from our initial FeOH2. Let me know if there's any questions at this part, chat. Let me know if you're still following along, and if I confuse you, drop that crying emoji so I can see what I missed. Let's check the chat here. What did I miss? Okay. What did I say? No wrong answers. All you have to do is pick the correct answer. I know the answer is by at least the stoichiometric coefficient. Okay, so the stoichiometric coefficient is back up here. So here's the stoichiometric coefficient. Let's go ahead and bring a copy of that because we ran out of space. So let's bring a copy of that so we can all see the question at all times. Okay, once I upgrade my laptop, I'm gonna be able to show everything at the same time. But for now, we have to just kind of cut that off for a little bit here. Okay, so this is going to be our next question here. So what do we do next here? Let's make this bigger. So here's that reaction here. So let's make this bigger, and what do we got to do next here? The answer is zucchini bread, 1/3, 0.01187. Good job, W. Bro's afraid to pull up that loud out calculator. I am, and not that I'm afraid, it's just annoying. It's all good. I said that during the poll. Got you. All right, so what we're gonna do next is gonna be what we're gonna do next is repeat that again. Okay, I'm seeing that we're basically gonna do that again for our moles of H3PO4. So I'm gonna take my moles of H3PO4 is 0.025521. So I'm gonna take my 0.025521. Okay, that's moles of my H3PO4, and I got to repeat that process one more time. So this time, what's going to be my molar ratio, chat? What's going to be my molar ratio to convert my moles of H3PO4 into my moles of Fe3PO4 here. So what is my molar ratio here? What's going to be my molar ratio? That's going to go up on top here. Okay, I'll give you a hint. So I'm going to start with canceling out the moles of H3PO4. Moles of H3PO4. And gosh, this thing is pretty cooked. H3PO4, just like that. And then I'm going to put my moles of Fe3PO4 too. So notice that this one never changes. So this mole ratio stays up on top. It never changes. So I'm going to leave that as a 1. But this time we're going to do a 2. Good job, everyone. So if you said 2, good job. Okay, so it's a 1 to 2 ratio. So that way I can cancel out my moles of H3PO4. And then I'm going to take that calculation once again and take my 0.0255521 divided by 2. So now I'm going to get a 0.01. It's tedious, but hopefully you realize it's not that difficult. It's a long process, but it's not too anything out of this world here. Okay, this is going to be our moles of product. This is again moles of Fe3PO4 from H3PO4. Now you already know what I'm going to ask you next. Now you already know what I'm going to ask you next is going to be step 4 is determine the limiting reagent. Okay, determine the limiting reagent. So I'm going to ask you another poll here. I'm going to say is FeOH2 limiting or is H3PO4 limiting? So let's get that poll active here. Let me zoom in so you guys can see the numbers here. So these are the numbers that we're going to need here. These are the numbers, and we're going to say which one is limiting. Okay, so these are the numbers, and we're going to say which one is limiting here. So get that poll active one more time. Okay, and so we're going to say which one is limiting. So it's going to be basically the same reactants, okay, but let's just get rid of those. And we're going to say, this time let's ask which one is excess, actually, because I've been asking which one is limiting. Let's say which one is excess. Which one is excess, okay? And so if you think that Fe3PO42 is an excess, you're going to vote for a happy face emoji. If you think that H2O is in excess, no, excuse me, guys, I'm putting the reactants. Hold on. I need to do the reactants here. Hold on. I need to do FeOH2. There we go. And versus H3PO4. So there we go. If you think that FeOH2 is in excess, you're going to vote for happy. And if you think that H3PO4 is excess, you're going to vote for crying. 3 more seconds to think about it and 60 seconds on the clock starting now. Vote for the answer on the top left hand side of your screen. Tap the poll and select your answer. All right, perfect. We got 4 votes coming in, 4 for crying, none for happy. So everyone is saying that our H3PO4 is an excess. Okay, and if you said H3PO4, let me know why you said that was an excess. M, thank you for the let 'em cook. Wary, thank you for the heart me. And Leslie, thank you for the finger heart, my friend. Thank you, Leslie. Okay, show the moles from the molar mass. Show the moles from the molar mass. I'm showing these numbers because these are the numbers that are going to tell you here. These are the numbers that are going to tell you what we have here. Okay, I'm showing these numbers because this is all the numbers you need here. Okay, very good. So Jackson said bigger value. Fung said crying. Empress says it has more than FeOH2. Okay, good job. Only 5 seconds left, so make sure you vote for your answer down below. 3, 2, 1. All right, good job, everyone. Cook that up. So we got 6 votes for crying. So very good. So the correct answer was the excess reagent was indeed Fe3PO4. And so therefore, which one is limiting, guys? If if H3PO4 is limiting, then which one is our, if that one was excess, which one is limiting? Rather, that's what I meant to say. So which one was limiting? So if we basically determine that this one produced more, which means that this one produced less. So we have to determine the limiting reagent. It's whatever produced less product. So therefore, it's going to be FeOH2. Okay, FeOH2 is limiting here. Okay, so if they ask you for excess, select excess. If they want limiting, select limiting. And we are almost done with this problem here. We are almost done. It's a little bit long and tedious, but you have to act quick here. You have to act quickly here, and we're going to go on to step number 5. But before I move on, let's see some more thumbs up. Let's see if everyone is following along. If this is making sense so far, go ahead and do me a big favor and drop that thumbs up emoji. You don't see if you have enough moles to even consume the other. I'm not sure I quite understand. It contains more and will FeOH2. Okay, good job. Good job. So I think everyone is following along here. Brandon says you don't see if you have enough moles to even consume the other. You don't need to. You don't need to do that full calculation. All you need to do is see how much product is generating here. All you need to do is figure out how much product is being generated, and that's enough to dictate whether or not it's an excess. Okay, that's the beauty of the stoichiometric coefficients, because that's going to tell us how much is going to be produced. Okay, so very good. So that's going to be our limiting reagent calculation. And we're going to move on to step number 5, which is finally convert, okay, moles of Fe formed, moles of product formed back into grams. Okay, so we're getting way more consistent with our step-by-step calculation. We are on step number 5 out of 5. We are almost done. We started with step 1. Start with what you have. Always start with what you have and start by writing down the molecular masses. Step 2 is convert grams into moles. So we do that calculation. And then step 3, convert moles back into moles using our stoichiometric ratio. And last but not least is determine the limiting reagent and convert moles of the product back into grams. Cool. So now we're going to use our moles of limiting, which we said was FeOH2 was limiting. So I'm going to write down my limiting was 0.11873. 0.011873 moles of Fe3PO4. And all we have to do is back convert that into moles, chat. How do we do that? One more final calculation and we are done. What's that final calculation gonna be? Okay. Oh, Brandon says that's how I was taught. Okay, so Brandon gave another suggestion. So Brandon said you can determine the limiting reagent by calculating how many moles one will consume the other. That's totally fine as well, but I recommend this way, chat, because this way can save a lot of time. Okay, hello. You compare the product generated and compare it to the moles you got from the molar mass calculation. Okay. I literally learned limiting reagents from these live. That's really funny. That's really funny. I'm glad you're here, Jackson. I'm glad you're learning. Maybe you can learn, maybe I can teach you calculus during these lives. That would be fun. So the last thing I gotta do is my grams per mole, 357.386. That's my final calculation. So I'm gonna multiply this out by 357.386 grams per mole, and that should be my final result here. 0.011873 times 357.386. Loud out calculator, and my final answer should be 4.243 grams of product. And woohoo, chat, we are done. Okay, that's the final answer. I know it's long and scary and painful, but that's the general procedure. You have to act quickly. Okay, break it down step by step so you can calculate each one by one. And if at any point you missed this, don't worry, I'm going to be posting the live stream tonight, so you can rewatch the entire thing tonight. It doesn't apply to this question though, because the products generated are both less than the molar mass moles. Okay. So yeah, in this case, we can just directly calculate that. Now, what other things can they ask you? They can ask you which one is the excess, which one is going to be the how many moles of reactant remaining. So we can calculate that. So Brandon is suggesting, how do we get our moles of remaining reactant? So guys, if we want to do an extra step, which is calculate the moles of remaining reactant or grams of remaining reactant, comment yes, show. Comment thumbs up, show it. If we want to move on, comment move on. Okay, sig figs. Okay, now we got to do sig figs. Thanks for the reminder. So thanks for the reminder. We got to do sig figs. So we're only going to have 3 sig figs here. So I'm going to round this one down. I'm going to round this one down to 4.24. Okay, I got to do my sig figs here. We got 3 sig figs here. Okay, my chem professor scared me for a little. I'm studying part of Poly Specialist Diploma Biomedical and Pharmaceutical Engineering. Okay. Difficult to understand the add match. Oh, so you're studying this in school? Okay. So what questions can I help clarify here? So M. Perez says, let's do the next part. So I'm going to do an optional part, which optional is going to say how many moles, how many grams of excess. The optional part is how many grams of excess remain. Okay, so we have grams of excess remain. So we're gonna go back to step 3, and we basically gotta use our moles of product formed. So we're not gonna use our limiting one because that was limiting. We're not gonna use our excess one. We're gonna use our limiting one. And so we basically said that FeOH2 was limiting. So we gotta use this number again. So remember when I used the 0.011873, I gotta do that one more time. 0.011873 moles of Fe3PO42. All right, now what I gotta do, chat? So now what I gotta do? Which one was our excess? Do you remember what you voted for? Remember, everyone voted that our H3PO4 was excess. So now I gotta do a backwards calculation and back calculate my moles of product back to the reactant. So I gotta go backwards now. Usually we were going forwards, but this time I gotta do a backwards calculation. So I'm gonna take 1 mole of Fe3PO4 to 2 moles of H3PO4. Okay, so 1 mole of Fe3PO4, 1 mole of Fe3PO4 to 2 moles of H3PO4. Okay, so I'm basically going to multiply that number by 2. So I'm going to multiply that number. I have 0.011873 times 2, and that's going to be a 0.0237. And that's my grams consumed. So this is my grams consumed. What's the final thing I have to do, chat? If this is my grams consumed, I don't want consumed, I want remaining. So I have to go back to my original question and say, hey, I started with 2.5 grams. That seems awfully low, though. That seems awfully low. Okay, but no matter. It's a big molecule, so I think it's fine. And it's going to be basically 2.5 minus that value. So I'm going to do my 2.5 minus that. Okay, 0.0237, and that's going to be my final answer, and we should be done. Hopefully there's not too many, hopefully there's no typos here. So this was a live problem here. I've never seen this before, I've never attempted it before, so this is me solving it live for the very first time, so you guys can see my thought process of how I get that. So this is grams of H3PO4 remaining, but if there were any typos, do bear with me, do be patient. Hopefully this was helpful anyway. I just have not double checked if there were any typos here, unfortunately. So let's do a quick recap. Guys, how are we doing? If this is helpful, drop some thumbs up and let me see how we're doing here. Let me know if this was helpful, and if you're taking chemistry right now, comment chemistry or say I'm taking chem right now. Okay, and yeah, guys, welcome into the chat. If you're new here, comment new so that we know that you're new. And if you've been here before, you know that we're locked in every single week. My name is Dr. Andrew. I go live Monday through Thursday right around this time, 6 o'clock PST to 9 o'clock EST. Guys, it's been about 1 hour today, and we're doing some live Q&A for general chemistry. So if you have any questions about Gen Chem, feel free to drop them down below. If you think you need tutoring, you can sign up for a free session on my link in bio, or join the Discord, which is totally free. ZMD is new. Welcome, Sammy. Welcome, Mina. Oh, Julia, Julis, and Sammy is new. Okay. Brandon, I can definitely do trig sub if you're taking calculus, but unfortunately, twin, we got to do Gen Chem today because that won the vote. So next time, try to vote in the poll and invite all your friends early to pick the topic that you want to go over. And Julius says I have an exam on Tuesday. And Gorilla says, let's do fugacity or real gas law. So Gorilla wants to do chemical engineering. Guys, anyone that has never been here before, my name is Dr. Andrew. My PhD, guys, is in chemical engineering. Believe it or not, I struggled so much with Gen Chem when I was taking it in high school and college. So that's why I'm out here to provide free resources. And yeah, guys, so I'm recording all of this. So if you missed any part of this, you can rewatch it up on my YouTube channel. Okay. Do you do cross sections too? What do you mean by cross sections? Okay. Sammy says HNMR and CNMR. Guys, let's do another quick poll. Let's do another quick poll to see because I'm seeing lots of things that are not Gen Chem. So we're gonna do another quick poll here. So are we gonna do basically the same? Oh, thank you for that. Thank you for the hand hearts. Guys, do we want to do the same topic or a different topic? So if you want to do the same topic, you're gonna vote for A. If you want to do a different topic and change classes such as mathematics, general organic chemistry or physics, make sure you comment D. Okay, but let's get that poll up. Let's do 3 minutes on the clock to give everyone time. Guys, how's everyone doing this semester? Are you feeling good or are you feeling kind of cooked? Is everyone surviving or are you feeling you're getting cooked here? Okay, guys, wait, hold on. The poll is active starting now. Okay, the poll is active now, chat. Make sure if you commented, make sure you vote on the top left here. Okay, and yeah, guys, we're gonna keep it going for another 40 minutes. So make sure you stick around. Vote in the poll, top left hand side of your screen. Vote for the next topic here. While that's going on, I'm gonna go ahead and see what is the main thing to talk about. Oh, cross sections in Calc 2. Yeah, absolutely. So cross sectional area. Okay, yeah. Cross sectional area. Okay, so far we got 2 votes for Gen Chem, same topic, and 2 votes for switching the topic here. Jackson says Kerbal Space Program. Julius says low key I'm cooked. If you're cooked, don't even worry, twin, because I got you covered. Guys, I have tutoring available for math, chem, physics, gen chem, organic chem. Okay, so if you need tutoring, just hit me up. You can either DM me here on TikTok or Instagram. You can sign up for a free session at the link in my bio. And yeah, guys, that's why I'm out here every single week. Because like I said, I was cooked when I was in college. Back then, cooked wasn't even like a word. Like back then, cooked meant literally for cooking. And so I was literally cooked, but I didn't even know it. Okay. Yeah, SN2 reactions as well. We did that earlier today. We actually started with SN1, SN2. Yeah, our first topic was SN1 today. Okay. So far we got 3 votes for the same topic. Interesting. So 3 votes for more stoichiometry here. So I'm guessing that a lot of people are still doing stoichiometry. So make sure you check out my YouTube channel, guys, because we've been doing that all month long. And I totally get it because I was in that situation. Once again, I struggled so much with stoichiometry. I understand it. It's just like seeing just to reinforce it more. Yeah, absolutely, Brandon. We can definitely do more SN1, SN2. And guys, if you want to join the Discord, this is the best opportunity. Just go on the link in bio or go to engineeringminds.co and then click on this link that says join Discord. If anyone is in the Discord currently, comment the word here so that I know who you are. And yeah, guys, the reason you should join is because we are a vibrant community of supportive STEM lovers and STEM students. So there's going to be tons of engineers, STEM majors, future doctors, future engineers, future everything there, guys. So super excited to have that Discord. So highly recommend that everyone joins because it's totally free. So why would you not join? Okay. And yeah, that's where you can ask your questions. And we do extra free tutoring in. Okay, that's Julius says I just need to practice before more because I low-key forget during exams. Exactly. If you forget during exams, that means you have test anxiety. And don't worry, that's really common. Everyone experiences test anxiety, guys. Okay. Sammy, good to see you. And so if you experience test anxiety, that just means that you're not dumb, you're not a bad student. It just means you need a little bit of guidance or you need a little bit of like support to help you, feel better during those exams. Okay, again, I've been there. I used to have, guys, I used to feel really, really anxious during my exams. The morning of, oh my gosh, my stomach was feeling like crazy every time I had an exam. So totally been there, guys. So again, that's why I'm out here, because the more you practice, the more you actually see the concepts, that's going to help you lock it down. All right, so that was our first problem, and everyone still voted for stoichiometry. So we're gonna continue with that second problem because everyone said stoichiometry. So we've been doing that all semester long here. So guys, this is kind of the same idea here, same idea. So I'm just kind of like, what problems? I'm running out of problems is my question. So what stoichiometry problems should we do? Do you guys have your own problems? Should I make up my own, or should we just talk about stoichiometry in general? Okay, so let me just go ahead and check the Discord, see if there's any other problems that people submitted, because I'm running out of problems to solve. Yeah, so I'm gonna probably just use my textbook here. Probably just gonna use my textbook, and I'm gonna do a problem here that we can solve together. Okay. I'm taking Gen Chem, but we're learning some OChem material. That's right. Sometimes you learn a little bit of organic chemistry. Okay. So guys, I'm going to give you a reaction and I'm going to give you what the compounds will be. And then our job is to kind of repeat that whole process once again so we can see step by step process what we're going to do. Okay? All right. So I'm going to open up my textbook here and we're going to basically do another stoichiometry problem because people said they want to do stoichiometry. So I'm going to go into this book. I'm going to look for a random reaction. Okay. So let's do like, guys, question. Should we do an easy one, medium, or hard? Should we do a high school level one or a college level one? Should it be easy, medium, or hard? Comment down below. Okay, so I basically have some of these, and I found some of these here. Okay, here we go. Okay, these look pretty hard. So these look pretty hard, and then some of these look pretty easy. So let's see what most people are saying. Okay, hard, college, medium. Okay, let's do a quick poll. Let's do a quick poll. So if you want to do easy, the topic is stoichiometry. Okay, so that's balancing reactions, etc. And then if you want to see a hard one, let me know here. So, okay, here's that poll here. Let's get that active. Got about 10 more seconds to think about it. So we're gonna do stoichiometry for about 20 more minutes here. And guys, if you want me to do an easy problem, you're gonna comment, you're gonna vote for a happy face emoji. If you want me to do a hard one, you're gonna vote for a crying emoji. 60 seconds on the clock starting now. Make sure you tap the top left hand side of your screen to vote for the poll here. Okay. Twin, can you talk about IR spec conjugation, Sammy? If you're taking organic chem, then guys, we gotta focus on. Oh, but you said you're taking Gen Chem. Oh, that is an organic chemistry material. So IR spec is basically your Okay, we can do that next. Let me add that to the list. We're gonna do that right after stoichiometry. We're gonna add that to the list. Okay, everyone is saying. Oh, everyone is saying hard. Okay, everyone is saying you want to see a hard one here. Some more hard ones here. Okay, let's lock in for a hard one. So I'm gonna just add that to the list. It's gonna be IR spec. Okay, 8 seconds left. 6, 5, 4. Last chance to vote. Last chance to vote. Okay, so guys, we're gonna lock in for a hard stoichiometry question. So basically, we're gonna do this here. All right, and let's see. Let's pick a hard one here. Okay. All right. So, okay, we're gonna lock in for this one here. So I'm gonna give you this compound here, guys. We're gonna do this stoichiometry reaction. I'm gonna write it down, and then this is gonna be This might be our last one for today because, well, it's a hard one. So let's see how long it's going to take. Okay, so we have 2C6H5Cl plus C2HOCl3 and C14H9Cl5 plus H2O. Okay, and so what they gave us was 1,142 grams of chlorobenzene. Or guys, next time we can do it, and we can do a chemical engineering problem. Next time we can do chemical engineering. Okay, if you want me to do chemical engineering next, comment chemical engineering. Okay, basically we want to do the whole spiel and calculate, basically repeat the whole process. Mass of excess. Basically we need everything. So yeah, this is probably going to take the whole time here. So guys, we have this problem here. It says DDT, an insecticide harmful to fish, birds, and humans, is produced by the following reaction. 2-chlorobenzene plus 2-chloral equals DDT plus H2O. In a government lab, 1,142 grams of chlorobenzene is reacted with 485 grams of chloral. A, what is the mass of DDT is formed? B, what is reactant is limiting? What is excess? C, what mass is the excess reactant is left over? And D, what is the actual yield of DDT is 200 grams? And what is the percent yield? All right, everybody, we're going to lock in for this problem here. So, whoops, didn't mean to close that. Here. All right, everybody, I'm going to lock in for this problem. So I may or may not read the chat here. I'm going to go quickly here, but if you get confused, try to help each other out in the chat below. I'm going to lock in because this is going to take a while. So I'm going to introduce myself one more time before we get started. Anyone that is new here, welcome into the chat. My name is Dr. Andrew Sanchez. I do have a PhD in chemical engineering. If you've been here before, comment the lock emoji because you know we're about to lock in. This is going to be our next general chemistry problem. I'm going to do my best to explain it as easy as possible. I do want to let you know I go live every single week, Monday through Thursday at 5 to 8 p.m. PST or let's say 6 p.m. PST or 9 o'clock EST. And if you want to join the Discord, tap the link in bio. If you need to sign up for tutoring, sign up for tutoring at the link in bio. And there we go. We got some Chem, Unk, Engineering, and Jackson lock in, Zane lock in. All right, guys. So that's all that good stuff. So I may or may not see the chat for a while. So if someone has questions, go ahead and help them out. We are going to go ahead and start by getting the molecular masses just like last time. Step 1, start with what you have. Okay, I spelled excess wrong. Okay, start with what you have. And I'm going to go ahead and just get my reactions. Here is a C6H5Cl. I'm going to make a small little table. And I'm going to basically calculate my molecular weights. Okay, and I'm going to do my first guy here is 2C6H5Cl. So I'm going to go to C6. I have 6 times 12.011. Okay, plus, okay, H5. So that's 5 times 1.008 plus 35.45. So I'm getting my first compound here and just cruising through this. Okay, and if you missed the live stream, just rewatch the YouTube video later when it comes out. Okay, this is going to be 112.556, basically making a table here. This is going to be in grams per mole. Repeat that process for C2HOCl3. So that's going to be C2 is 2 times 12.011 plus 1.008 plus oxygen is 15.999 plus 3 times 35.45. That's going to be 147.376. Let's repeat that process again for our DDT. Is C14 is 14 times 12.011. 14 times 12.011 plus 9 times 1.008 plus a 5 times 35.45. That's going to be 354. 0.476. By the way, this is kind of what engineering is like. It's a lot of calculations and you have to be quick. This is really reminding me, I want to say this is almost at the engineering level. It's still at the high school, it's still at the college level, but it's kind of similar to engineering because this is a long calculation here. All right, and then what I'm going to do is basically calculate the moles of everything that I have. So step one is convert grams into moles. Step one, convert grams into moles. Okay, so I'm gonna basically use what I have here. I have 1142 grams divided by that molecular weight was a 112.556. And that's gonna give me my moles of that first reactant. And notice how I'm making like a nice little table here. Okay, so I'm gonna put my moles here. I'm basically putting a nice little table here to keep it nice and organized. 1142 divided by 112.556. So I'm going to put 10.146 moles of C6H5Cl. So that's going to be 10.146. And then this is going to be our next calculation here. And similarly, I'm going to repeat that for 485. And it's going to be 147.376. Okay, and I'm going to do 485 divided by 147.376. And it's going to be 3.290 moles. So guys, this was a hard one. People wanted to see a hard one. Here we go. This is it. So we gotta just go quick. 3.29 here. Now we have to do our that was our step 1, step 2. So that's gonna be our step. That was really step 2. Step 1 was start with what you have. Step 2 is convert grams into moles. Step 3 is convert moles into moles. Moles to moles. So we need to do it for our main compound here, C14. So thankfully it's already balanced. So I'm going to take my 10.146 moles of C6H5Cl. Okay, and then I'm going to do this is a 2 moles of C6H5Cl times 1 mole of C14H9Cl5, and that's going to be this number divided by 2. So I got 5.073, and that's going to be my moles of product. No, I don't do every topic every single day, but I just do whatever people vote for. C14H9Cl5, and that's going to be from C6H5Cl. And then I repeat that process again for my second reactant, which is my 3.29 moles of C2HOCl3 divided by my 1-to-1 ratio. So I'm not even going to finish writing that. It's 1-to-1, so it's going to be the same exact number, so I can just rewrite that again. And I know that's going to be my limiting because that's going to be my generated product. H9Cl5, that's going to be 3.29. Again, I've never done this problem before, so hopefully I'm not making too many typos. Okay, so my 3 is less than my 5, so therefore my C2HOCl3 is limiting, and so I basically produced 3.29 moles of this guy here. 3.29 moles of product was formed. Now I have to back convert because it said this one was limiting, so I'm going to box that. That was step 1. Part A said which one is limiting, so I got C2HOCl3 is limiting, and then therefore the other compound is excess. And then Brandon says that's the excess. Brandon says that's the excess. So I got C2HOCl3 is limiting. Okay. What happened there? And then let's see. If I get a negative number, that's going to show me that I'm wrong. Okay. If I get a negative number, that's going to tell me if I'm wrong. If I get a positive number, I'm going to assume I'm correct. I said that when you wrote the first calculation. Okay, got it. Oh, my bad. And then what mass of the excess is left over? What mass is left over? So I'm gonna take my what mass is left over? So I'm gonna do what mass is left over. Okay, so I'm gonna take my 3.29 moles of C14 H9 Cl5, and then I gotta back convert. Wait, yeah, that was my back convert, and then back convert that into moles of excess, which is gonna be my moles of C14H9Cl5 per mole of my excess now is my C6H5Cl, so this is a 2 C6H5Cl, and then that's going to be my next calculation, so that's going to be 3.29 times a 2, and that's going to give me 6.581. Okay, that's going to be 6.581 moles of excess, which was C6H5Cl. And now I gotta do my 6.581 moles of C6H5Cl times, I gotta back convert grams into moles. So I'm gonna multiply by my 112.556. And that's gonna give me 112.556. That's gonna give me 740.836. And the final step is I have to subtract that from my original 1142. So I'm going to take my 1142 minus my 740.836, and that's going to give me my final answer, minus 740.836, and that's going to be 401.2 with 4 sig figs. 4 sig figs. Oh, actually, we should have 3 sig figs. So it's going to be about 401 grams remaining. And last but not least, so that's our second answer. That was part A. This is part B. And then for part C, it says if the actual yield is 200 grams, then calculate the theoretical yield. So theoretical yield, calculate the yield. So then we're going to take our actual versus theoretical. So we're going to take our actual, which is 200, divided by 400 times 100%. And guys, we were so locked in. I hope someone was timing me. How long did that take? I got 49.9%. And we're done. Okay, let's go back to the chat because I've been totally ignoring you here. But that was our total solution here. And yeah, guys, so that's basically this calculation here. We basically did a hard example here where we had these complicated numbers, complicated processes. Given was 1142 grams and 485. Maybe I'll upload this onto the website or I'll drop it in the Discord. Okay, because that one was pretty fun to solve. Any chance you can help me with this synthesis problem for Orgo 2? Yeah, I think we're gonna basically keep it going here. Let's see if we want to do, or I kind of want to do Orgo, guys. Thank you, Lena. No, you. No, you. Okay. And we basically went through this, and yeah, hopefully this made sense. Sean, any chance you're in the Discord? Sean, if you're in the Discord, let me know so that that way I can see your question here. And what kind of synthesis is it? Is it going to be like alcohols? Is it going to be carboxylic acids? I'm in EpiChem right now, and I'm doing integrated rate loss. Can you help with that? Yeah, absolutely, absolutely. So, basically gotta basically do a poll here. So, I'm getting more things for Orga. So to join the Discord, just go to the link in bio. Okay, if you want to join the Discord, and then I can help you guys out with Gen Chem, OChem, Math, Physics. Just go to engineeringminds.co and then click join Discord, guys. It's totally free, so there's no reason why you shouldn't join. Just join in and introduce yourself, and yeah, have a good time here. Julia says it's like easy, but when I do it on an exam, I go blank. I know, twin. That's why you have to basically keep practicing, okay? I know it feels easy, and then I know you go blank. That means you have to just keep practicing it over and over and over until you get it down, okay? Be patient with yourself, twin. It's not going to make sense in one single day. It's going to basically take a lot of practice, okay? I actually do a lot of self-studying even when I'm not on live because I'm really, really passionate about this stuff, and I try to find enjoyment. As soon as you make it fun, it's gonna start to feel really, really fun. It's gonna start to help you, motivate you, and it's gonna start to be really, really interesting. It's really cool that you know everything. I don't know everything, twin. I just know a few things here. Okay, I'm just older than you. I'm not really that smart here, guys. I just know more things because I'm older here, and then I just got my degrees here. So thank you, guys. You're so nice. Gen Chem so easy. I knew everything a few days before, but I didn't practice enough, so I failed. Okay, guys, we're gonna do a quick lock-in for organic chemistry. NBA edits. If you can join the Discord, twin, so that way you can drop in your questions and I can help you out for free. So hopefully you saw how to join. Just click on the link in bio and then click on join Discord, and then I'll help you out in there. So you can drop your questions in the Discord channel. So guys, I think we're going to do another quick review for organic chemistry. And guys, what topic for organic chemistry should we do? I'm going to be on for about 10-15 more minutes, and then I'm going to end it for today. Okay, but I'm going to be on for about 10 or 15 more minutes, and then I'll end it for today. And then I'll be ending it for today. I stream Monday through Thursday at 6 p.m. PST, 9 o'clock EST. Okay. And yeah, guys, so we're going to basically do organic chemistry, and everyone's been asking about SN reactions. Okay, can you do acids? pK values like ranking. Okay. And then Sammy asked about conjugation. So guys, we only have so much time, so I'm gonna go one at a time. We only have so much time, so okay, 2 questions for acids and bases. So I think I'm gonna do acids and bases followed by SN1. So let's start with acids and bases first. Okay, and remember, guys, what is the definition of an acid and base? And then, guys, let me make sure that everyone sees let me plug my TikTok real quick because I already have a ton of videos on acids and bases on my TikTok. Okay, so if you go to my page and then click on the playlist, click on the chemistry playlist here, and then look up hashtag chemistry. I have 83 videos on chemistry, and a lot of which are acids and bases related. Okay, but let's go over it anyway, so you can review that and then also watch the stream later today. So you can check that playlist and review acids and bases. So what is the definition of an acid and base? What is the definition of an acid and base? And remember, now we're switching gears here to organic chemistry. So I'm going to start assuming that you already know your Gen Chem. So hopefully you remember from your Gen Chem, what is an acid and a base here? Okay, basically going to have, for instance, water is going to be our first acid or base here. Is water an acid or a base? Is water an acid or a base here? Suppose that I have water here, and my water here is basically going to function as what? An acid or a base? Okay, exactly. Brandon said proton donor or proton acceptor. Okay, so a proton acceptor is going to be our, so our first guy here is going to be a proton acceptor. So one water will function as a base, and the other one will function as an acid here. So this one's going to be the proton donor, and that's going to be represented by this reaction here. So one water molecule goes up to the other water molecule here and steals that proton, right? And so that reaction is going to be represented by the formation of H3O plus hydronium and hydroxide, OH minus. Notice that we started neutral, no charge, and then we have a plus charge and a minus charge. So we started neutral, so we have to end neutral. Super important that you guys get that down. We start neutral, we end neutral. If we start with the positive side, we got to end with the positive side. Okay? So water is very interesting because it's going to act as an acid or a base. Now, let's do a harder compound. Let's do, for instance, hydrochloric acid. Now, is hydrochloric acid, clearly it's an acid, so I'm not going to ask you that easy, but is hydrochloric acid a strong acid or a weak acid? Okay. Is it because of the partial positive and negative? Yes and no. It's going to have to do with the acidity of that molecule. It's going to have to do with the electron affinity. And it's going to be determined by a few different factors. Okay. So is HCl a strong acid or a weak acid? Okay, is HCl a strong acid or a weak acid? Okay, and what's the difference between a strong acid and a weak acid here? Okay, very good. Ali's world. Okay, HCl would be a strong acid. Very good. So Ali said HCl is going to be a strong acid. So I'm going to deprotonate that. Okay, and then I'm going to basically bring this out over here. Guys, this is something that I go over every single week with my organic chemistry students. So if you need help with organic chemistry, make sure you sign up for a consultation call. I do private tutoring and group tutoring. Okay, so here's our proton donor here. Acid is our proton donor, and then we're going to generate our H3O plus and our conjugate base Cl minus. Again, notice that we started neutral and we ended neutral. Plus minus cancels out. We're going to have neutral. Okay, and cool. So now let's do a weak acid. So for instance, I'm going to give you this compound over here. So this is a acetic acid compound here. And here's going to be our proton. So I'm going to highlight this proton is nice and ready to get plucked over here. So this proton is nice and ready. And once again, I'm going to take my base. Let's say I have a minus charge this time. Let's say I'm going to react this with sodium hydroxide. Now, I'm going to have NaOH. And everyone always asks me, oh, if I have NaOH, how do I know what it's going to be? Is it going to be an acid or a base? But remember, recall your Gen Chem. Sodium hydroxide is going to dissociate in solution. It's going to form Na plus and OH minus. So if you forgot this, you have to review your general chemistry. So that's going to determine that our OH minus is going to function as the base here. And the base is going to attack this proton here. It's going to eat. I like to say that the bases eat the proton, and the proton is going to donate that back into that and generate. Once again, this time we started with a minus charge and a positive charge, so we started still neutral here. Okay, or in other words, if I get rid of that sodium here, we started minus here, and so if I started minus, I got to end minus. So I started minus because I'm ignoring the sodium because it's a cation. So my HOH now formed a water. Okay, if my OH minus attacked my H, what did it create? What is OH minus plus H, chat? So someone comment down below. What is OH minus attacking an H going to form? Okay, that's going to form H, O, well, that attacked an H, so it formed a water molecule here. Okay, hey Jess, yeah, I recorded this today, so you can watch it later up on my channel. And we did Gen Chem 2, twin, so I know you're taking that. And very good. So this is our acetic acetate ion here. So again, notice that I started minus and then I ended minus here. Okay. Water. Brandon was right. Water. I think I sent the photo in the chemistry section. Oh, Sean, thank you. So guys, let me check that right now. Let me check that section. Okay, perfect. Ooh, that's gonna be tough. I'm gonna do it off screen because I'm not gonna have enough time, so I'm gonna try that one off screen. So Sean, thanks for joining. Make sure you introduce yourself and welcome in, guys. If you want to join the Discord, just tap the link in bio. And so Sean dropped a question in here. I probably won't have time to answer it now, but I'm gonna answer it later. And guys, we're gonna end it very soon, unfortunately, because I do have to head out. So we're finishing up acids and bases in organic chemistry, and then we're gonna end it very soon, guys. But don't worry, I will be back tomorrow, and I'll be posting this for you to review any practice problems you might have missed today. Yes, please join. Just go to engineeringminds.co and then tap join Discord. Okay, it's totally free. Guys, we're gonna end it in about 5-6 minutes. So this is your last chance, guys. Any questions about acids and bases so far? Let me check the chat. You can drop questions in the Discord or up on the website. So in these reactions, you're deprotoning the strongest the proton in the acid. Exactly, right? I'm deprotoning the strongest proton. How would you do decomposition of table sugar? Decomposition. What do you mean decomposition? Is that OChem or Gen Chem? C6H12O6. Decomposition. Do you mean combustion? Is this Gen Chem or OChem? Yeah, please drop it. If you can send it, that would be fantastic. So in these reactions, you're deprotoning. Yeah. Should have joined earlier. Taking physics, taking OChem. Yeah, twin. If you need help with OChem or physics, I got you for both. Can you do one with multiple protons in the molecule? Okay, guys, we're gonna talk about pKa real quick, and we're gonna talk about pKa, and then we're gonna end it for today. So the best example I can think of for multiple protons is gonna be our carboxyl or amino acids. And amino acids are really important because we are made of them and we eat them every day. So we eat our food, which contain our healthy amino acids. So an amino acid is going to be a simultaneous acid and a base. So amino acids are really interesting because it's the same compound, but it's going to function as an acid and a base. This right hand side here is going to function as the carboxylic acid section here. So this is going to be the acid. And this ammonium over here, this ammonia NH3 group is going to function as the base. Now, I do have some videos where I talk about pKa. So please check the videos where I talk about pKa. But I basically tell you that pKa is the acid Riz level. That's right. I have a PhD in doing TikTok streams. Okay, so the pKa is the acid Riz level here. And so that's going to determine if the acid got Riz or no Riz. So if it's a low pKa, that means no Riz. Okay, so strong acids have no Riz because they fully deprotonate. Okay, so strong acids have no Riz because they fully deprotonate. Okay, and then weak acids, and then so strong acids have low pKa because they have no Riz, so that's gonna be strong acids. And then bases have high pKa. Okay, So they have high risk because they're going to want to stay together. They're going to be greedy for that proton. So this is going to be strong bases. Let's call this bases. Okay? So this section is our acid section. So its pKa is going to be pretty low, approximately 2 to 3. Okay? So that means that it's not going to stay together. It's going to break up with this proton. Compared to this NH3 is going to be a base. So it's going to have high pKa of approximately 9 to 10. Okay? pKa is going to be approximately 9 to 10. And guys, unfortunately, this is all the time I have today. I'm going to pretty much end it here, but don't worry, I will be back tomorrow. I will have every single week, Monday through Thursday at 6 o'clock PST and 9 o'clock EST. Guys, thanks so much for today. We hit 10K likes, 26 new followers, and a ton of new gifts here. We got heart meat, rose, and hand hearts. Guys, I will be posting up this stream later tonight on my YouTube channel, so make sure you sub on my YouTube channel. Last but not least, if you need a tutoring session, make sure you sign up for the link. Make sure you sign up for tutoring at the link in bio. Just go to engineeringminds.co, book your free session. The first one is a totally free consultation call. And then you can also join the Discord, which is also totally free, and explore the resources. Okay. Thank you guys so much. Again, I will be back tomorrow. And yeah, guys. Thank you. All right, peace out, my friends. I'm gonna end it here, and I'll post this tonight, and I'll see y'all tomorrow. Welcome in, Ali. Make sure you introduce yourself. Well, I'll see you there. I'll see you in the Discord. Anytime. Peace out. See you tomorrow. Stay safe, everybody. Stay safe.